Welcome to the panel on technical debt. I am your host, George Fairbanks. I'm delighted to be here. It is a fulfillment of a, I won't say childhood dream, but an adult dream to introduce this illustrious panel. I've had the pleasure once before of moderating a panel and was completely unable to pronounce Mr. K's last name. Many of you may have felt the same concern. Let me introduce the panel. First, we have Jeromy Carrière of Google. He's an engineering director. And we have Rod Nord of the SEI. You may have been to his session just before this on technical debt. We have Philippe K, who's a professor at University of British Columbia. I thought about having a slide which had the guys from Men in Black and just having K on there. I thought that would be good. Rebecca Wirfs-Brock, she gave me a lovely story, which is she invented technical debt. I'm exaggerating a little bit, but her first job was programming in COBOL for 4 months, and she hard-coded all the numeric constants right into the program. And we have Michael Keeling of IBM. We're doing things a little bit different than you may have seen this before. You notice we have the Twitter live feed. So we will be taking questions, running around with the microphone. But if you can contribute constructively, not graffiti, not making jokes of the presenter, not making jokes about the host or whatever, MC either, feel free to post to the Twitter feed, and that would be great. One last thing. You guys have those pieces of paper that they distributed before with the columns on that. Have you seen those? The ones that have the grades for the things, those are due now. You need to get on those, okay? Because your vote matters. If you don't vote, the wrong guys get the award. So please, 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 please turn those in. Each of the panelists here will have 1 minute as a position statement. They've prepared these position statements very carefully. We have a volunteer who will be setting off a beeping timer at the end of 60 seconds. So without further ado, let's start at the end with Jeromy and give us your position here.
Cool. When do I start? I feel like I'm on a racetrack. I get 1 minute. Okay, so first of all, I love technical debt. It's awesome. It's great for the same reason that financial debt is great. It's the reason I have an apartment in Manhattan. It gives me flexibility, right? I get to choose where I put my funds when. I can borrow now when the cost of borrowing is low, and I can pay it back later when the economics change. Second, I define technical debt as the delta between a quality function applied to my system as it is built relative to that quality function in the ideal state. That delta, that gap, is what I would consider the principle if we sort of push the debt metaphor. That leads to my problem with the technical debt metaphor compared to financial debt, in that in technical debt the principle can change. In fact, it's changing all the time. That delta between what I've got and what I want is continuously changing because the environment is changing and my goals for the system are changing. Finally, okay, I'm done.
All right, Rod.
So Philippe and Ipek Koskaya and I have been involved in a series of workshops on managing technical debt for the past 5 years, and we're seeing great progress. I think there's a definition in a landscape that's emerging. We're starting to see communities of practice in organizations dedicating people to this topic and increasing tool support. But I think one important challenge that we still need to make progress on is in metrics. So we really don't have reliable metrics to quantify technical debt. So we're still limited in showing trends in other metrics. For example, if complexity increases, does that really mean that debt is accumulating? So at this conference, I think we've seen a lot of great metrics for operational qualities, things like availability, for performance. So I think the challenge is can we as a community start to create some developmental metrics? So are there automated measures to surface technical debt issues in a system before it becomes difficult to maintain, before it becomes a problem? So maybe together we can share data and experiences and results.
Go.
Measuring technical debt, what a challenge. We can sometimes equate technical debt with low quality of the code, and we can try to extrapolate that to architectural debt. Is it low quality of the architecture? Maybe not. Maybe we have a very high quality architecture, but still experience technical debt. Steve McConnell added something to his definition of technical debt. If you're not paying any interest on it, maybe it's not technical debt. And this actually connects with what Jeromy said. So we still need the reasoning of the architect to identify what technical debt is. We can't just trust tools and quality metrics to sort of pinpoint it. It all depends what are you going to do with the system from now on. Not so much what we've done with it in the past.
Okay. All right. So I'm being a Portland native. Part of my job here is to channel Ward Cunningham into his thoughts about technical debt into this audience. His original definition of it, I think, is quite interesting to reflect upon because it says it accrues when we don't reflect what we've learned as we've built systems back into how we're building the systems today. And so in some sense, I think one of the challenges for the architectural debt that Philippe was talking about or whatever is to, if things are stable and not changing, and even if their quality is at a certain level, we might want to treat those differently than things that we want to change and evolve quickly. So I think that managing debt has to be based on the sustainability of and the rates of change of what we're building. Okay. Done. Okay.
All right, so what is technical debt? Well, in my experience, technical debt is a wishy-washy metaphor that offers an all too convenient excuse for developers to write crap code. All right, technical debt is completely misunderstood. It's abused. But it's also an extremely powerful tool, right? And that makes me feel very divided about how we treat this tool. So let's see here. So on the one hand, to extend the metaphor, probably not for the last time throughout this panel, I can treat debt or treat software as an architect almost like I would a portfolio, right? Looking at different aspects of the architecture and making investments or paying down as I go. But at the same time, it's still just a metaphor, right? I can't measure it. I can't actually have any quantifiable way to understand how I am really doing. So it can be very, very dangerous at the same time. It's just gut feeling, right?
All right, great. Thanks very much. We kept the position statements very short so that you guys would have a lot of chance to ask them questions. I'm going to ask the first question, as is the prerogative. And then after that, you guys please just raise your hand and I'll walk over with the microphone and I'll let you do your thing. Also, please, the Twitter feed. So my question to you guys is, I'm going to pose a situation. I'm a tool vendor, and I say I can detect 100% of technical debt by running my analysis across your source code. What do you say to that? Anyone, jump in.
Bullshit.
BS?
I was going to say how
And I'll
much.
say, show me.
Then what percentage can I detect? Oh, that's harder, isn't it?
This was actually part of the discussion we had in the previous session. The various tools that we've been using to supposedly measure technical debt, they measure some indicator that is vaguely connected, vaguely correlated with technical debt. They do not measure technical debt. Therefore, we cannot say that which percentage or which type of technical debt they measure. They measure some qualities on the code, but the quality of the code at whichever level is not technical debt.
Anyone else?
All right, so an obvious thing with code tools is that it's only looking at the code, right? And so there's probably other aspects of your system that is not necessarily discernible just from the code itself, right? So there might be design aspects, right, that might not be directly observable or require a knowledge that is above just form and function, right? Is that Challenge to you. Any rebuttal?
But I think that also came up in the discussion at the end of Bill Opdyke's keynote yesterday, and that there's so much we can learn from the code. Maybe it's not directly measuring technical debt, but there's some symptoms or some correlations. So then can we make use of that architectural knowledge either to kind of calibrate that measures, or maybe they need to be used in conjunction, some kind of lightweight analysis to help guide the code, and then vice versa. Some things that are good, for finding hotspots in code analysis, then can focus the experts.
So I want to stop talking about the code and some of the technical debt that perhaps we could analyze when we choose as architects to use two different frameworks or go to the next version of whatever, Struts 5.0 or whatever. And we don't go back and reflect or correct or repair things to do things in our consistent way, then we're creating multiple paths of confusion for anyone, and that kind of debt, I think, is something that we as architects should think very carefully about. So oftentimes we want to do new things and new technologies, and they will improve the way we do things, but we don't ever go back usually and say, and we need to fix all the other stuff because, but maybe we should be thinking about the cost of multiple solutions or multiple maintenance approaches to things. I think that's something we as architects could do something about, I hope.
Anyone, if you have questions, please just raise your hand and I'll come on over and help you. Okay, coming over. I'll ask a question real quick. So Ward Cunningham had this idea of technical debt as defined as, when I look back at the system, I want to repair the things that I would have done differently if I'd known then what I knew now. What if your coworker thinks you should have done different things? And what implications does that have for the definition of technical debt?
It's subjective, hey? That's part of the problem, isn't it? So if I think I should have done something differently, in some sense, if I don't get an opportunity to perform that experiment, at least to extrapolate and prove to someone, then, that's not going to grow learning within my organization. Now, if someone disagrees with me, what I don't want to have is a implementation bake-off, but maybe we ought to be doing some of that notion of set-based design where me and my buddy try alternatives and maybe we pick a third approach. I don't see enough of that in critical areas of systems these days.
George, is it a matter of taste? I like my solution better than your solution? Or is one of the two solutions preventing us to go forward? That's the only question that matters. It's not whether I like it, or it's nicer, or it's more elegant, or this is the way we should have done it. It's, does it prevent us to go forward?
Well, I think we can always go forward. It's at what rate and at what cost, maybe. We can always make almost anything work. So.
But as Philippe had pointed out, or Jeromy, there's the notion of interest too, and even though that's subjective to some extent, we can start to think about what is the extra work or the rework. So maybe take some advantage of learning from lean or agile practices, and think about what's the extra work that we're doing that's causing friction or drag.
I did try an approach at one point, not particularly successfully, to actually at the end of a sprint have the some tech lead on the team actually document the technical debt that they believe was incurred during that sprint. So the shortcuts that they took for the sake of expediency or for whatever other reason, document their at least notion of what the interest is. How much time did they save by taking that shortcut? How much risk do they see in it? And at least that way, maybe we can't measure debt, but we have a portfolio to manage over time. Again, wasn't a lot successful, so take it for what it's worth.
So everybody always has their little list of things I want to do. I mean, any developer does, right, that I'd like to tweak, give me time and I'll go do, and I think that, I guess I'm wondering why that wasn't that successful. Did they not have the time to get to tweak?
Yeah, I think it was just a lack of commitment, like at various points in the organization. I don't think there's anything fundamentally. I didn't say anything that indicated it was a fundamentally flawed approach. It just wasn't. We just didn't put our minds to it.
Yeah. So I just like talking about refactorings, there are the things you might do daily, but then there are the things that might take a little bit of time and energy. And are we investing in repair, as a valued activity for sustaining what we're doing? I mean, I think that consciousness is something that, since it's hard to quantify the value of that, because things keep working, we make things work. So that's part of the problem.
I know, you're waiting to ask your question, and we just keep jumping in here. All right, just a couple of quick observations, all right? I'm getting confused up here a little bit, okay? We keep talking about different levels of technical debt, if you will. So I'm not sure if we're talking about like micro-level kind of programming or macro-level kinds of architecture sorts of things. It seems like in terms of measurement, we keep going back and forth between value and cost. Right, so what is the value that I'm actually providing, or the potential value that's available, versus the, say, cost of rework or the cost of not doing a change, right? And I think with kind of traditional views of technical debt, we always talk about cost of rework, right? That's not providing any value at all to the customer, right? It's just rework. And I guess the last thing, we were just talking about design a little bit. Are we talking about design, or are we talking about coded structures, right? So, if we're talking about design, I think we have a very clear way to evaluate those things with, say, quality attributes, system properties, right? So we should be able to definitively say, my design is better or worse than something else, at least at a certain level, right? And maybe at that micro kind of code level, we don't have a good notion of that. We have things like code smells, right? Is that really the same sort of thing? Just some thoughts and observations so far.
Yeah, but there's an aspect of technical debt, as Jeromy pointed at the beginning, that is actually a technical investment. We're taking some shortcut in order to gain some advantage, maybe on the market, maybe by being earlier, by capturing part of the market, knowing that if we are successful, we'll have to repay that investment.
You don't have to. Just ship it and let it go.
Pay the interest.
Right? Now you have your little, maybe you never have to touch that code again, or maybe it's years from now, or maybe you replace it with a framework or another library. You just throw away the junk that you wrote, right? Knowing that it was kind of mediocre or just served a short-term need.
Okay, replace with a framework, that's repaying your technical debt.
Mm-hmm.
Touché, sir.
Stay classy.
So my question is, it's always a struggle between, agile and architecture, and how architecture actually involved in agile. And when we're talking about technical debt, right? When you're coming in a company where they're in a transformation state, and in previous years, the architecture has no value whatsoever. And now you're coming to the point where system pretty much come to the halt. So what's the responsibility of an architect and actually enforce that we fix certain technical debt? Because at some point, it's just becoming constantly fixing the problem, and it's just a never-ending cycle where people working 24/7 to address the bugs, where what we're missing actually a foundation in the first place. Does it make sense? I don't know. It's very loaded question.
That was a very depressing story.
This is the reality in a lot of companies.
I'm not sure I see a clear connection between agile and technical debt and architecture, but let me try to sort out a little bit into what you said. Iterative development allows people to experiment earlier. So instead of building on paper an architecture that you'll see running in 18 months from now, and then you discover that you've made the wrong choice, you can actually discover that you've made the wrong choice, or even, decide for the wrong choice now, relatively rapidly. So I see some value in doing this iteratively. Whether you take or not technical debt has nothing to do with iterative development, agile or non-agile. The technical debt existed long before agile was even used in our world. So I don't see a clear connection to them. Now, at the level of piling up a lot of low-quality code, some very rapid iteration may push you into that direction. Yes, but that's not necessarily intrinsically linked to agile. People have done bad code even before agile stuff.
Since the dawn of time, yeah. But there is this view of some people in the Agile community that says that I'm going to do things and make decisions at the last responsible moment. And depending upon your corporate culture, that could be always too late, so that you're always, making that debt nudge over. And I tend to think that's what probably, when you're characterizing Agile as maybe being a cause of that, it's when people essentially use their Agile values as an excuse for taking on more risk than they know they should.
No.
No.
We have two on deck already. So let's go to the next.
Okay, so I don't know how it is here in the States or in other countries. In our country, the government companies, for example, well, they are very restricted with the investment and the funding and all of that. So if you, let's say, come out with something like technical debt, then that will have some pretty nasty implications, like, okay, you maybe just wasted the money and didn't do the right job the way you should have done it. So for those type of, I don't know how it is here in the States, but how would you deal with that type of situation? You have a technical debt, and you have this sort of, let's say, things to fix, but on the other hand, you have these legal restrictions.
Call it something else.
Yeah.
Just change the name. Call it like backlog of awesomeness or whatever. That's fine. Because it's like if you're making rational decisions, like, doesn't matter. I appreciate the optics of like calling it
Things that you've postponed to release 2.
right for the sake of rapid delivery of release 1. People love that.
Or maybe try and reframe the debate. I think Michael challenged us yesterday to put the humans first, and we're not always rational. So I heard an interesting analysis of if those of you that follow American politics, whenever the budget and the debt default comes up, it's been pretty fiery debate. But in February, it actually the debt ceiling came up and it passed without any incident. And there was an analyst that talked about the power of words, because and I think it kind of resonates what you were asking and with Agile as well. If we kind of frame the discussion of kind of extending the debt ceiling, that gives us the thought that we're putting more money on the credit card, we're spending extravagantly, or maybe we're spending for architecture that's we don't really know the value. But by saying instead, like we want to avoid default, then default, at least in that context, is more of a emotionally charged word. And by engaging our emotions as well as our cognitions, the idea is to kind of surface that tension, and so that we can then remember it and then be motivated to act. So I think maybe we need to change the word, or maybe like technical debt, what we're working on with architecture is to think about it more strategically, to kind of avoid default. And so now there's a positive aspect to kind of pay off that mortgage for something that we already have value, and we continue to want value.
So avoiding default, I still think, has a negative connotation. Maybe it's like to create a sustainable business or something. You're right on the, I don't know what the right terms are, but if I'm creating a sustainable development velocity by doing these activities. That's a better way of saying it, or what?
Well, this, yeah. Well, the analyst was kind of saying, I guess it's, being emotionally charged, because so being kind of responsible, like according to him, is kind of boring, to people, but
boring but
having,
works.
Yeah, kind of default catastrophe engages the emotion, but then kind of channeling it, as you say, more to a positive connotation, over the long run in terms of value.
But people don't like to, at least in my state where I live in the United States, we're very bad at taxing. You have no sales tax. I notice you've noticed that, right? And our schools are going to hell, right? Because we don't have funds for our schools, and we've laid off hundreds and hundreds of teachers over the year. And so we've incurred educational debt because we don't want to take on the expense. And so you still have to, at some point, get the investment into reducing technical debt, or you degrade your ability. So how do we get that turned around? I think is an interesting sell. Maybe it's like, one way to do that is to, with every feature goes some debt reduction, and we just bake it into what our estimates are. That's sort of sneaky, but I don't know.
I mean, we do that anyway, right? Whether you get in, you try,
I never
you get
do
in,
anything I
you
don't
find
have
some
to do.
crappy code, you kind of refactor a little bit as you go, right? What is it?
Maybe
You should if you don't.
Depends on how much time I have. But I'm saying, maybe you should. I know a lot of people who don't because they're pressured. So, anyway.
Let's take another question.
Okay.
So I've operated primarily in iterative, agile style environments. And Jeromy, you mentioned one tactic which you think wasn't very effective for managing technical debt in these kind of environments. I'd like to challenge the panel. Tell me, what do you think is the best tactic? I know there's many variations across teams and so on, but what is your favorite tactic for managing debt in an iterative development team?
All right. So just to clarify, what do you mean by manage?
Reduce.
Is it reduce? Is it maintain?
Not grow out of control.
Okay.
Let's just say you don't want to the campground metaphor. Leave it just as leave it at least as good as where you got it.
I can fund my retirement, right? In the financial metaphor.
Unlike what Jeromy experienced, I've been very successful in having teams identify technical debt and put it on their backlog as visible as features that they need to do and technical stuff that maybe not end up in features, so that at least people are conscious. We have choices. We have limited manpower. We have a few cycles ahead of us. What are we going to tackle for which reason? What are the dependencies? Can fixing that technical debt now will help us do something later on? Do we have a little bit more time in this release cycle to tackle some of the technical debt? At least it's visible on the same level as the other elements that you should have in your backlog.
So, I think I actually believe a lot of technical stuff should be on that backlog, and this sort of agile, as a developer, it really sucks that I can't do whatever. Should be equally valid stories, or I'd like to be able to do this. And there was this original view of the backlog as being pretty much feature-driven, user, product owner-driven. And I think that the whole team owning the backlog is kind of with a balance, is kind of a good thing to do. On the other hand, you got to get the whole team buy-in to do that, and Philippe is very persuasive, obviously. But another technique that I think is kind of a helpful thing, if you don't have a culture that lets you do that, is to have things like after you have a release, you have the FedEx days where people get to fix stuff, or you have after you have a major release, you have I won't call it a relaxing sprint, but a technical sprint, because the team gets to do that once a year or whatever. They're all things that you introduce different things into your rhythm that allow you to do that.
If I may comment on what Rebecca just said. After a major release in Vancouver, people go skiing in Whistler, but okay.
And then you come back on Monday and give them, or whatever, and let them do something. Yeah.
One advantage of putting your technical debt very visible on a backlog is that it exposes it also to other people that are not, software developers, people like product owners and business analysts, and maybe even the ultimate customer, if the customer is involved in your development. It's not just a dirty little secret of the developers.
Right, yeah.
All right, well, I'll just go ahead and chime in with some simple stuff. Discipline, having a culture of caring, that's a good tool, but that's also really hard. And kind of, I guess, some practical things. Pair programming is pretty good. Static code analysis, I think we already talked about that and beat up on it a little, but it does give you some indicators, right? Some things to think about. So, data that can feed into proper planning, as Rebecca was alluding to, things like that have seemed to work pretty well. But I guess it's more people issues than it is anything else, right? Culture.
So I think also there's some other tool things that as architects you might want to do. If you see people making things that are, I'm going to say, debt-laden, error-prone, we had the notion of like architectural hoisting, building tools that make it hard for people to do the wrong thing. If those kind of tool builder, whatever those little tools are, can really, really, really help. Like, how do I check stuff in correctly, whatever. And so if you have tool builders, people who love to be those little tool builders, that can really help too. And make your own,
Technical debt usually is related to collateral. And if I'm going to borrow money, I'm not going to put my son as collateral. Is there an analogy to things from an architecture perspective, being a leader, an influencer in how a product is being developed, a collateral that you cannot put as technical debt from your experiences? Where do you want to draw the line?
I mean, you got to ship something, right? Hopefully your code left. Is that collateral enough, or?
My question is the thing that you can't compromise. You can't.
Right. Yeah.
Okay.
I don't think there are any.
Stuff that's off the
I don't think there are any absolutes. Like security people love to say security is unviolable, right? But it's not true. Like it's only a matter of risk evaluation. Some things certainly are sufficiently risky that you can't trade them off, but there's no blanket that you can apply. Blanket rule you can apply to everything, in my experience.
I guess I'd say there's one thing off the table is that if you don't have any sort of tests, if you can just deploy anything without any sort of testing of at least what you care about, whether it's functionality or qualities, at least some minimal testing is not negotiable in my point of view. Because if I want to make changes, I need to know that things are still not, I'm not breaking things when I'm redoing. So I actually feel pretty strongly about testing, not necessarily at the TDD level, but the right set of coverage tests that you want to have.
So I think tests are imminently tradable, but to disagree with Rebecca. The one thing that actually I will put on the table is undermining trust of a team. So you trade off too long in too many ways, and by management declaration or whatever, and you lose your team. They go away, especially at Google, right? Google doesn't work. Like you can't do that at Google.
So I'd like to follow up on a few things the panelists said and a question that just came up here on Twitter. Rod, you talked about using technical debt as a way to frame an understanding, and I would say all of the ugly code or ugly problems we've got, technical debt is a subset of that, okay? And Philippe, you talked about multiple different kinds of things you put on your backlog besides features, technical debt being one of them. So are there other words or other concepts like technical debt that are distinct from technical debt that we should be distinguishing and talking about and perhaps putting on our backlogs?
Tests.
Yep.
Sorry, go ahead, please.
Test. Right.
Rebecca's going to lynch me.
I'm thinking of things like desserts that should go on the backlog.
Yeah. No,
Voodoo
uh,
donuts.
Other decisions that we make when we develop code, we also make decisions not so much about the code and how it's designed, but we make decisions about how we get organized, how we structure teams, which people we pick, which process we use. And sometimes the technical debt is also at the level of the decision that we've made in the organization. When I look at technical debt as a form of friction, well, there is friction in the code. It's hard to evolve, hard to scale, how to change. But there's also friction at the level of the team that developed the code. It's hard to evolve, to change. It has some ossified structure that doesn't fit what we want to do anymore. So there's other aspect of debt that may not be technical debt in the sense that we've been using over the last few years, but that's actually affecting the progress as much as, you know, bad dependencies and cyclic dependencies and code smells. Sorry.
Wait, so what is your question? What goes on a backlog?
What else can go on a
backlog?
Let me say it again. So
Okay.
technical debt is not meant to be all bad things that have happened in my code, right? It's not just the run-of-the-mill bug that counts as technical debt.
Right.
It's things that I said, hey, I think I'll do this in an inelegant way deliberately now, that is borrow, and I have to pay it off later, right? That's the genesis of
Right,
this whole thing.
right.
So there are other, we can put that on our backlog. The question that was on Twitter
Fix that
and
hack.
right.
Yeah,
So
right.
so what other sort of categories of things should we be paying attention to and perhaps naming?
So I was answering this. I would say we need to change the team. We need to train people. We need to hire different people. We need to fire some people. We need to use
Hopefully not on the
another
backlog,
subcontractor. We need to change customer. I don't know.
Keep it visible.
Those things are also changes that we may want to do.
So, talking about a backlog of work to do that involves writing or producing new features is one, you know, the traditional use of a backlog. But I also think that you can put on the backlog, besides, you can do things that if you really want to track activity in the architectural world of what you're doing, if you're, you know, you might put on tasks of architectural investigation or running empirical evidence, you know, getting numbers, getting data, doing prototyping, all these kind of activities that are consuming the time of developers and architects can go there if you want to have them be visible, right, and manage them. So, yeah, those things can go on there. That would be
Fixing defects. Curiously,
Sure,
if things do
yeah.
not show up in the backlog, they're in some other database somewhere, you know. And therefore not prioritized with the rest and evaluated like the rest.
I was actually fishing for the multicolored backlog stuff that you've done. So anybody
This
who
is
hasn't
why I
already
was trying
Googled
to
that,
complete
or I mean,
with the
sorry,
false
used the
elements.
search engine of your choice. Okay. Question here.
You're gonna hold. George kind of stole or segued into my question, I think. It seems like there's the technical debt you consciously take on, that you say, we're going to do it this way, we know we're going to have to change it later. There's the stuff that sneaks in. You did it one way, and later, in hindsight, you realize that, oh, we do need to refactor. That's the stuff that Bill Optic was talking about. There's also occasionally a new target architecture. We've gone a different direction, and we realize now what was okay before has become technical debt. Do we need to address those in different ways, the different types?
Jean-Louis Le Touzet calls this a technological gap. Basically, the landscape has changed around you. You were doing the right choices, but the context has changed for various reasons. You've become successful. or some other technologies have evolved around you. And yes, now you're in technical debt, although you've made the right choices at the time you made them. So yep, we've looked at that. When we drew that diagram a few years ago with the landscape of technical debt, we had a little slot there for that specific kind of technical debt that we incur just by letting time flies.
So there's also that kind of, time flies, we keep using this technology that isn't exactly suited for what we're doing, and we keep writing more and more stuff or putting more and more data in the databases or whatever, growing things at wrong rates and building onto it. So I think we do need to manage those differently, because in some sense it's so easy with those things to be like the boiling frog syndrome, where, oh yeah, I guess it's getting a little slower to do this kind of repair or add this new thing, but and you just keep dealing with it. So at some point I think you need this sort of heightened awareness of those kinds of, boiling frog technology changes, because when there are gaps like that and you just live with them for 5 years, how many people are still running on Windows XP, for example, and then like, my God, what are they going to do, So, and that requires, I think, a serious, investment in infrastructure or whatever, and those are not the same thing as like repairing what I did wrong. This is like, oh, time to do something new.
Yeah, I mean, so debt itself, it's a pretty harsh metaphor, right, for having made all the right decisions in a lot of cases. And so kind of the way I've been thinking about things, we keep talking about paying it down, but sometimes it's good to have debt, and sometimes it's not. But nobody likes to have debt. Everybody wants to be debt-free. But and then we make all the right decisions, but then the world changes around us, and now we've done something bad, even though we did everything right. So I don't know. As an architect, usually I end up talking about options more than anything else, right? So it's not about what decisions I made, but rather what choices I have available. And I mean, perhaps pivoting on the metaphor slightly, as stock options. I have the choice of making some decision at a later time at an architectural level. That's very, very powerful. From a debt perspective, it could be just a slightly different way to look at the same type of thing, or just a really crazy mixed metaphor. But
yeah, I think metaphors, as you point out, only go so far. But the point is that you only pay down debt if you view something still as an asset. Otherwise,
right.
You divest, right? So we need to have some words about talking about that, because I oftentimes get called in when things are really way beyond repair.
Right. Okay. Just to review, like what can we do? We can pay it down. We can throw it away. We can replace it, with something else. What are their kind of actions for paying down?
Buy an alternative. Yeah, that's replace.
Okay. So
yeah.
Replace or fix ourselves. That's pretty much all we can do.
Yes.
Bankruptcy, or just go broke.
Divest. Yeah, from that thing.
I think our code, or things in general, can have two types of properties, intrinsic and extrinsic. Intrinsic properties would be like the complexity of the code that can be quantified. Extrinsic properties would be something like architecture that its meaning can change by the day, just by as the world changes, our knowledge about the world changes. And I think as a tool, and not just as a concept, technical debt should be concerned about intrinsic qualities. It has very limited meaning, but that's all you have. If I have a loan in the bank, I can be sure that this is not by tomorrow 10 million out of suddenly, because the bank manager tells me, yes, the world has changed, the knowledge of the world has changed, and I would never take a loan if that would be the condition. I think if we talk about that in terms of technical debt, it's not a good tool to track projects, to talk to management, it's a good tool if you have, if you know what you're talking about and you have intrinsic properties that do not change by the day.
Mhm.
No reaction from the panel?
Well, yeah, well, I think what you're talking about, yeah, in certain cases, I mean, it would be desirable if we knew everything and we can, treat it purely as an engineering, discipline. I think, Walker Royce, Murray, Cantor have talked about that. Maybe, with these extrinsic, properties, or, Rebecca was talking about set-based design, or Michael about options, is really need to shift the conversation. It's not purely a engineering conversation, but it's one about economics and economic, governance. So there are uncertainties in the world, and we need to, think about that and kind of, building that into the process. So, realizing that we have these uncertainties and kind of exposing them, early, perhaps is debt or improvements that we have to make. That's the way of the world, if we want to be agile in the business sense in terms of kind of responding to a rapidly changing world.
So technical debt is not a sharp technical scientific concept that can be very well defined. But it's pretty useful. It has some value. It has the value of allowing us to have an extended discussion, bringing more people in the discussion about what do we do now? Where do we go? How much is it going to cost us? Do we want to do that? What value will it bring? So it's a sort of rhetorical concept, not a scientific concept.
All right, so why are we trying so hard to measure it all the time? If it's really just a thought experiment or a conversation piece.
It's a tool.
Or I guess we started with this was saying, I guess you can't measure technical debt, right? We can measure the things around technical debt. That was the tooling question, right?
So you can look at how things evolve over time. Maybe there is no absolute measure of technical debt, but you can localize it. You can give it a name. You can see, is it decreasing, increasing? So the tools may give you some hint into, are we going to be better or not? It also sometimes allows you to put a little bit of weight on the discussion.
A topic was brought up early in the panel that I'd like to revisit. The idea of refactoring and technical debt are tightly tied concepts. That the idea is if something's not right, you come back and you fix it up later, which is probably some kind of refactoring. We're here at an architecture conference. Class level refactoring is easy to do. It's so parsimonious with time that you can just do it, probably don't even need to tell your manager. If you have architecture level technical debt, what are your strategies for dealing with this? Because it's probably something that's going to take you more than an afternoon to get fixed up.
Well, so if you think about building architects and the bridges around Portland, I don't know if you've noticed, any of you have driven across the Selwood Bridge where they actually had to rebuild the bridge and they've moved it sideways, and next week it will be closed for 4 days while they're moving it the other way. One way to deal with it's an amazing feat of engineering. And if I have those kind of architectural problems, one of the things that I can do to do debt is to provide bridging strategies where I do things a new way in a limited fashion while I'm fixing it up and then moving things over gradually. None of these things, or I can migrate things or redefine schema, or all these none of them are easy when you have these major architectural refactorings, and usually anybody doing them that I have seen be successful does these sort of small. They don't just I'm just going to go do this. They perform small experiments, empirical evidence, and they have these complex bridging strategies if it's a big architectural thing. They don't just go all gung-ho at once. So it's a much harder problem.
Yeah, so we fake it till we make it, right? You put wrappers around stuff, you hide things. The best way to do it is to I guess, plan for change, right? So you kind of have to architect the ability to evolve over time. And I think that there's a lot more awareness of that. I think the microservices talk, or the microservices idea that came up this morning during Diane's talk, and I think Len Bass was talking about it on Tuesday. Joe Justice was also talking about that with respect to a car, but it still applies to this
Modular,
conversation.
yeah.
Right. You kind of have to plan in the idea that you're going to have to move your bridge. Right. You don't build the giant castle on the side of a mountain that is going to be the fortress of all time. You just plan that it's going to change. So I guess the tricky part is what happens when you didn't plan that, right? And it's just painful, right? Maybe it doesn't move. Maybe you can't change it. And I guess that's just a really harsh reality.
I think that actually back to Diane's talk, Netflix has done that, right? They took the castle that they built on the mountain and they broke it up into a whole bunch of little whatever. I'm going to give up on the analogy. Microservice. Like they did it, right? And so it's hard, but it's possible.
Well, yeah. I mean, that's what I was talking about. Kind of fake it till you make it, or whatever. Putting the wrappers and the transition, right? But even like a good three-layered, or multi-tiered kind of architecture could lend itself to, incrementally building in services, right? So I think if you actually planned ahead and have some kind of notion of what your architecture is, and maybe if you're following some styles, or are at least aware of your design in some way, that probably gives you an opportunity to evolve at least from style to style, right? But I guess if you're not following any of that, I guess what do you do, right? You have to make it up yourself.
All right, we've got 5 minutes left, so the last question will be here for Mr. Updike. Dr.
Okay. Actually, I had a question here because there seem to be a number of related issues that I think companies would sometimes run into in this sort of thing, which is if there's an interest in addressing technical debt, is it something, how do you go about documenting, or is that worthwhile? And then if you do, what do you document? And then finally, if it's documented, what do you do with the information you've gathered in that area? And I was especially interested in what your thoughts were on that third issue. If you assume for a minute that an organization agrees that it's valuable to capture and document the technical debt issues, and that there's a set of them have been gathered that are fairly, say, representative, what are the kinds of things that you think an organization should do with that information moving forward?
Well, what you shouldn't do is punish your developers, right? So definitely don't do that.
I go back to portfolio management. Like, see where you have both high risk and high interest rate. Chance of a balloon payment looming. Pay those off first, right? And sort of work your way through it like a portfolio, understanding and continuously reevaluating that risk interest sort of profile.
Also look for trends over time. There might not be kind of an absolute measure of when an optimal payback strategy might be, but by looking at trends and seeing how things are changing, that might provide some hot spots for further analysis.
What other potential evolution depends on repaying this or that technical debt? If there is a large amount of other possibilities that this opens, it's probably more valuable to fix this one rather than this one, which has relatively few dependencies on it. But also looking at the defects that you have, maybe some of the technical debt is related to defects. There may be some technical debt that you may want to repay because a lot of defects that are being discovered are related to something that is structurally not good in your code. Again, it's all depend of where do we want to go from where we are now.
There's always this tendency, I think, that people have of, can I just keep patching the road that I'm going down? Or do I need to make a major investment? And it's always easier to sell small sets of investments. And that's actually really hard when some of the technical debt is because I used the wrong tool and it just no longer is going to handle the scaling. I mean, I'm thinking of some of the cases that I've encountered. And so it's almost when, if you can document the cost of change, it's not that I just always want to do the easiest one, but I want to do the one that's going to make the continued work more sustainable at what level I want to invest in. So if things get harder and harder and harder and harder and harder to do because there's technical debt, where I've seen that, those are usually the things that need an investment, but usually they're hard, and then you need to have this bridging strategy too. So it's not an easy answer, but you have to view debt reduction as a kind of a longer term strategy in those kind of cases. So there's nice easy wins, that's great, wouldn't it be nice if we have those, but then there are these longer kind of multi-pronged kind of approaches. And you can't take on too many of those big ones because it sinks your whole budget and your effort. You've got to pick the hot ones.
Okay, so one of the ways that we use it, this idea, or one of the ways that I could see this working very well as well. So work with your product management, right? So if you have a good understanding of where your problem areas are, what you can do now is work directly with your product manager to get the future state, right? Is there a direction that the market is headed over the next 6 months that we need to be prepared to address, right? Go ahead and start preparing for that now by maybe cleaning things up a little bit. So, it's not only about addressing quality, but it's also about creating value, right? And creating opportunities for value in the future. And you can do this in a very strategic way if you kind of know what you're looking for and what you need to do. I guess most organizations are probably very reactionary, and that's why we have rules of thumb like the the Boy Scout rule of code check-in, right? You just clean up a little bit as you go along and hope for the best, right? Tidy up the bad code.
Okay, guys, we have one last question. It's for the entire audience. Could you do me a favor and raise your hand if you happen to have a pen or a pencil on you? Excellent. You are well prepared to fill out those forms for voting for your favorite presentations. So we're going to lock the doors and keep you away from the dessert until you drop the forms at the desk here. Let's all give a big round of applause. Thank you for the panel.